Welcome back. Today's lesson is measures of variation. Our learning target is 6SP3. We're going to recognize that a measure of variation describes how a set of data values vary with a single number, which is going to be confusing and a lot of vocabulary today, but basically at the end I can calculate the measures of variation and can use that information to describe the set of data.
First off, we have a bunch of vocabulary to get started with. So get each of these pieces down. The range is the difference between the high and the low. This is the one we already knew from the last lesson with our median, mode, and range. Quartiles, think of quarters. Quarters mean break something up into fourths. So quartiles are values that divide the data set up into 4 equal parts. The first quartile is the median of the lower half of the data. So we're going to find the median of everything, and then we're going to find the median or the middle of the lower half. That's our first quartile. Third quartile is the median of the upper half. So now we're going to find the middle of the top part of the data. And then the interquartile range, or often referred to as the IQR, is the difference between the first and the third quartiles. That's a whole lot of vocabulary thrown at you very quickly. We got to get it down so you have something to refer back to, but then we're going to walk you through a couple of examples.
Okay, on the last slide in big red letters was all data has to be put in order first. We're lucky because our first example is put in order for us, so we can just focus on the vocabulary words. So
did I miss that on the last slide?
It is. It's okay.
I'm glad they saw it.
The range, the high minus the low, or the maximum minus the minimum, is really easy here because we're subtracting 0, so 8 minus 0 is 8. And then we're going to go ahead and cross them off like we did yesterday to find the middle number. So he's going
I'd rather not cross them off because I'm going to have to use them again. Can we do the dots?
You can do whatever floats your boat. Checks, dots,
we're going to have to find the middle of all of the data, and then you're going to have to find the middle of each of the halves. So rather than cross them out and then have to erase them, I'm just going to kind of mark them with the marker here. Remember, you can't take one from the left if you don't also take one from the right.
Okay, we're left with 2. We're going to eyeball that and call it 3.5. If we didn't, we would add 3 plus 4, which is 7, and divide by 2 to find our middle number of 3.5. Now, our 2 new vocabulary words are pretty much looking at the median of the first quartile and the median of the third quartile. Our first quartile is the lower half of the data, anything that falls to the left of the median. So are you changing colors? Yeah. So he's going to change colors or notation, and he's going to start crossing off the numbers to find the middle of the lower half. Again, we're going to eyeball that and call it 1.5.
So we call that Q1. We use the 3 over here because it wasn't actually the median of our data, so it's part of the lower half. So we just kind of sort through it. Oh, I forgot to write that down here for us. So the first quartile is 1.5.
So the median of our lower half of the data is 1.5. And now we're going to do the same thing. Include that 4 in the upper. He's going to cross off a high and a low. And he's going to find that the middle number between 6 and 7 is 6.5. Now, our next vocabulary word, the interquartile range, we're actually going to subtract our median of our upper data minus our median of the lower data. So 6.5 minus 1.5. Our goal here is to see how spread out our data is from the lowest data point to the highest, and then how spread out the rest of the data points are. So our range tells us our high minus our low, but our interquartile range of 5 tells us that most of our data is not spread out the most. Our median was 3.5, lower was 1.5, upper was 6.5, and it didn't spread out more than 5 throughout the data points.
So like Mrs. King was talking about, a lot of the stuff we've done so far is just focused on where's the middle or where's most of the data. Now we're looking at how spread out is that data. How spread out is the lower half, how spread out is the upper half, and kind of what is the range of all of the information instead of just focusing on the center. So let's tackle another one. It kind of takes a little bit of practice to get used to the problems, but remember our magic rule, before we can do anything else, we have to put all of our data in order. So I've got a 2, and a 10, and a 12, and a 13, and a 14. I'm going to kind of cross them out, especially this big list of data. We want to make sure we don't miss anything. Then I've got a 15, 17, and 18. And then I've got another 18, and a 20, and a 21. So first step was to write it all out. Find the easy stuff. Find your range. We go all the way from a 2 up to a 21. So we subtract the high minus the low, and we get a range of 19. Oop.
Okay, then he's going to get started on our median using a dot. He's going to cross off our high and our low and find our middle number.
Maybe I get lucky and there'll just be one number left
It
in the
is
middle.
15. Now this time we only have one number in the middle. We need to make sure that that 15 doesn't get in our lower data or upper data. It's circled, it stands alone, we're done with it.
So that's been used.
So now we're going to find the quartile 1. The median ends up to be 12 of our lower data.
So notice how I'm labeling it on the actual list, but then I'm also listing it over here.
And then he's going to go ahead and do it for the upper set of data, which we should end up with 1. I do.
If you get a nice middle number down on the bottom half, or in the lower half, you know the same thing will happen up here because you've split your data in half, so there's the same number of data pieces on both sides.
And then our interquartile range would be 18 minus 12, which is 6.
So we found the middle of all of the data, we found the middle of the lower half, that's the quartile 1, we found the middle of the upper half, and then we found the distance between those two numbers.
You're a little farther to travel on the lower end since it starts out with 2 and goes to 15, but it's only spread out 6. So we'll talk about that in a little bit.
Next piece, and this part's already written into your notes, but you're going to want to star or circle or underline this part. An outlier is a data value that is either much greater or much less than the median.
And they're easy to spot, but what we have to do is to remember the outlier comes into play. It's 1.5 times the IQR, so that's important to underline and write down for yourself. Go ahead.
So we're going to kind of show you how to use this here in a little bit, but the idea is we want to see, just because a number looks like it doesn't fit with your data doesn't always mean that's going to be the case. We have to actually calculate it out, find out if it really is too far from the rest of the data for us to count.
And this month of April, we're generally within the 50s into 70s, and last Saturday it was 28, so that was an outlier for April. Same thing is happening in this graph with the temperatures in Tampa. It looks like they were basically in the 60s or the 80s and the 90s, and then they had one day that was a 65 temperature.
So your first instinct is that 80 or that 65 doesn't seem like it fits with the rest. It has a good chance of being an outlier, but we want to find out for sure. So first step, like all of our problems, is put our data in order.
Do we have it all? 2 91s, 92, 93, 95. Yeah, we're good.
Did I get it all?
Yeah.
Okay.
So now we have to find the range. So he's going to start off by subtracting 95 minus 65 to give us an even 30.
So knock out the easy one. Now we find our range or our median. So we find the middle of our data set. Remember, you can't take one from one side if you don't take it from the other.
So circle that 91. Don't touch it. You're done with it. That's our median.
So that one's been used up for us.
And then go ahead and find the lower.
Here I have 2.
Fun, 88.
But halfway in between 88 and 88 is 88. So that's my first quartile. I'm going to do the same thing up top. I've got 92 and 93. So halfway in between 92 and 93 is 92.5.
So he's going to subtract 92.5 minus 88. He's going to line up his decimals and make sure, or use a calculator, whichever one, and get 4.5, right?
4.5 is my interquartile range.
Now, in order to find this, he has to multiply 4.5 times 1.5, which on a calculator is 6 for most of you.
So 4.5. Our interquartile range times 1.5 is going to give us what?
6.75, sorry.
Okay, I was going to say, I don't think it hits exactly there. So 6.75. So that's our magic number. To find an outlier, it has to be 6.75 below the first quartile or 6.75 above the third quartile. So
now, you can eyeball it and know that 65 is more than 6.75 away from 88, but we still have to prove it. So we're going to add to the upper, so 92.5 plus 6.75 is going to give us 99.75 for our upper extreme.
0.75? I think it should be 99.25. So we don't have any numbers.
12, 8, 9, it is 99.25.
So 99.25 is their upper limit. We don't have any numbers that were above 99.25, so there's nothing that's an outlier above the range. Now we come back to the first quartile, 88. We're going to subtract away 6.75. So 88 minus 6.75. This is
81.
why you're glad you have a calculator.
81.25. What are you doing? 81.25, and we do have a data point that is lower than 81 degrees. We have a 65, so the outlier we have now proved is 65, an extreme data point. And what that data outlier does is it brings down our data.
And kind of throws everything off. It's like if you're normally an A student, you do great in all your tests and quizzes, and then you had one real bad day where you got a 50%. That 50% is an outlier. It doesn't fit with your normal scores, but it definitely will pull down your grade in class. So hopefully that doesn't happen to you.
All right, are we
Next
gonna let
one, we want you guys to try this one for yourself. So put your data in order, find your range, your median, your quartiles, and your interquartile range. The outlier part is tough. So work back through how we just did that last example. Work through, can you figure out, are there any outliers in the data?
Can you write add to third quartile and subtract IQR, add to third, and subtract
So after you figure out that IQR times 1.5, you're going to add it to quartile 3, you're going to subtract from quartile
1.
Quartile 1, and then if there's any values above or below those limits, that tells you whether there is an outlier.
If there's not, you write none, but we do want to see that math.
All right, good luck, and we'll check it over tomorrow.